do one more example. Let's do this one in black. Example 3. Y cubed z plus y, 3x, oops, that's 3xy squared, 3x y squared z plus x plus z, and xy cubed plus y. Okay, so that's our vector field. Let's recover the potential function. Let's go ahead and make sure that all of the partials are equal. So we'll do df, so this is f1, this right here is f2, and this is f3. So df1 dy is going to equal, the df1 dy is going to be 3y squared z plus 1. And if I take d f2 dx, I get 3y squared z plus 1. So that checks out. Now I'll take df1 dz is equal to y cubed, and df3 dx, that's equal to y cubed. So that checks out. If I take df2 with respect to z, I end up with 3xy squared, 3xy squared plus 1. And if I take d of f of 3 with respect to y, I get the same thing, 3xy squared plus 1. And I hope that you are confirming this for me. I hope that I've done it right. Okay, so the first thing I'm going to do is I'm going to integrate this first function with respect to the first variable, x. Okay, so this time I'm just going to write it straight. Y cubed z plus y. I'm going to integrate with respect to x, and I end up with x y cubed z plus xy plus some function h, which is a function of y and z. Okay, so this is our potential function. Now I'm going to take this thing and I'm going to differentiate it with respect to y, and I'm going to set it equal to the second coordinate function, which is exactly what it is. So when I differentiate this with respect to y, I'm going to get 3x y squared z plus x plus dh dy. That equals 3x y squared z plus x plus z. Therefore, that is equal to that, because this is this, this is this, and so therefore we have these two equal to each other. So dh dy equals z. So I've got dh dy is equal to z. So now I'm going to integrate this with respect to y, because it's y here. So I'm going to integrate. So h is equal to the integral of z with respect to y. And that's going to equal z squared over 2, right? No, not z squared over 2. See, I made the same mistake. This is where you have to be careful. I'm actually integrating with respect to y. So z is a constant. So this is actually going to be zy. Zy plus some function of z. So be very careful. As you can see, I made the mistake. So now our potential function is equal to x y cubed z plus xy plus yz plus kz. So now I'm going to go ahead and take d dz of this, and I get x y cubed plus y, because this is 0, so plus y plus dk dz, and that's going to equal our third coordinate function, which is x y cubed plus y plus 0. Therefore, dk dz equals 0, which implies that k equals some constant, which we can always take to be 0. So our potential function for this particular vector field is, well, it's this thing, but k is equal to a constant, which we can take as 0. So what we left with is x y cubed z plus xy plus yz. There you go. That's our potential function. So once we know that certain hypotheses are satisfied, we can go ahead and just start to construct this potential function. And we do it by integrating one variable at a time. We take the first coordinate function, integrate with respect to x. We get our potential function. We differentiate that with respect to the next variable, which is y, and we set it equal to the second coordinate function. We match corresponding terms, and then we integrate with respect to y. Along the way, we recover an extra constant function. We differentiate that with respect to the next variable, z. We set it equal to the third coordinate function. We match corresponding terms, and then we integrate with respect to z. And then we put it all together in the end to come up with our potential function. And that's it. It's that simple. So really, the only thing that you have to watch out for here is pretty much the mistake that I made myself. Up here, we're integrating z with respect to y. Z is a constant, so this is just zy or yz. That's it. You just have to make sure that you're keeping track of the variable with respect to which you're integrating and any of the other variables inside. Okay, thank you for joining us here at Educator.com. We'll see you next time for the conclusion and summary of potential functions. Take care. Bye-bye.